In this lesson, we're going to talk about SATA storage devices. SATA stands for Serial Advanced Technology Attachment. It's also known as Serial ATA or just SATA. In this video, we'll just refer to it as SATA. This storage interface system uses a single cable to create a point-to-point connection between the storage controller and the storage device. There are a variety of different storage devices you can use with a SATA interface, such as hard disk drives, SSDs, and optical disks. SATA uses a serial bus architecture, which is quite different from earlier storage interfaces. A SATA bus is composed of two different channels, each consisting of two wires. One channel is used to transmit data, the other one is for acknowledgements. Within each channel is a transmit wire and a receive wire. There are also several other grounding wires within the cable, but they're not shown here. SATA cables can be up to 1 meter in length. One of the main design advantages of SATA is the thin serial cables that facilitate better airflow throughout the computer case. Because they're small, they don't restrict the air as much, and this allows you to have smaller computer cases. The SATA connector itself is about 7/8 of an inch wide and has 7 pins in a single row. The connector has an L shape to it that prevents the connector from being plugged in incorrectly. Storage devices can use the SATA interface to connect to and then communicate with the storage controller on the motherboard. This interface identifies the physical and electrical properties that allow data to be transferred from the storage device to the storage controller. Here you see a close-up of a SATA connector on a hard disk drive. This is how you connect the drive to the motherboard. In this example, you see that the SATA cable is red and plugs into the left side of the connector, and the power cable connects to the right side. Because SATA uses a serial connection, there are separate ports on the motherboard for connecting each storage device. Each SATA connector creates a dedicated channel between each device and the computer. Since the channel is independent, the bandwidth isn't shared with any other devices, which provides better throughput. SATA also provides a feature called hot plugging. This allows drives to be added and removed from the system while it's still running, which is also called a hot swap. This is especially helpful on systems such as a server, where powering the server down can cause network disruptions. Because SATA has been around for a while, there are several revisions and standards that have been implemented over the years. The first revision was called SATA 1, now known as SATA 1.5 gigabits per second. The alternate name comes from the fact that this revision transferred data at about 1.5 gigabits per second, which really isn't a lot faster than the storage standards that it replaced. SATA 2 was the next revision, and it supported data transfers that were much faster. These were up to 3 gigabits per second. SATA 2 had other enhancements that weren't included in SATA 1, such as native command queuing, or NCQ, which increases the I/O bus's overall performance. As you can imagine, the next revision is called SATA 3. SATA 3 supports data transfers of up to 6 gigabits per second. This revision is mainly used for high-performance hard disk drives, as well as solid-state flash drives. This standard also provides newer connectors for SSDs and thin optical devices. Be aware that the revisions we've talked about so far are designed for internal storage devices. There are also two SATA standards designed for use with external storage devices. The first one is called eSATA, which stands for External SATA. eSATA uses a special SATA connector to connect to external SATA storage devices. This standard is typically faster than USB and the old FireWire. Since this standard is used for external devices, one of the first things you'll notice is that instead of using the L-shaped connector we talked about earlier, eSATA uses a rectangular-shaped one, which means it has its own eSATA port. This cable also has a locking clip to help keep it in place. When you work with eSATA devices, keep in mind that the eSATA standard doesn't have a provision for supplying external devices with power. As such, these devices require an external power source. In other words, you'll have to plug the devices into a wall outlet. Although eSATA doesn't provide power for external devices, there is a SATA standard that does, called eSATA P. The P stands for power. This standard is sometimes called power over eSATA. It basically combines the functionalities of an eSATA connector and a USB port. It sort of merges them together into a single connector. Because of this, you can plug an eSATA device or a USB device into an eSATA P port. An eSATA P port combines the 4 pins that are used by USB 2.0 with the 7 pins that are used by an eSATA port. It also adds 2 more pins that supply power at 5 and 12 volts. This allows SATA data as well as device power to be carried on a single cable. With that in mind, let's spend a few minutes reviewing the process for selecting and implementing a SATA device. Before you buy a component to implement a SATA device on your computer system, check the component standard and the port interfaces. You need to make sure that you match them appropriately. In other words, you need to determine the standard for the interface used by your storage device. Then you need to determine the standard for the interface that's installed on the system. The two interfaces have to be compatible. For example, a SATA hard disk drive that uses a 3 gigabits per second SATA standard has to connect to an interface that can transfer data at least 3 gigabits per second. If you mismatch standards, the component will still work, but the connection speed is going to be reduced to the speed of the slowest component. For example, let's suppose you connect an older SATA 1 storage device, like an old hard drive, to a SATA 3 interface on the motherboard. The motherboard will be able to see the hard drive and write data to it, but the data transfer rate is going to be limited to the speed of the hard disk drive. You're only going to get 1.5 gigabits per second. That's it for this lesson. In this lesson, we talked about SATA storage devices. We talked about the SATA interface, and we reviewed SATA cables and the various SATA revisions. To finish up, we discussed the process of matching the appropriate SATA devices together.